Very good evening to all. I'm M. Ramesh, working as an assistant professor in the Department of Aerospace Engineering at SNS College of Technology. Today, I'm going to explain about the liquid propellant rocket systems. So, why propellant systems are there, and what are the major components and its applications. So, one by one, we can move on. In liquid propellant rocket systems, they are among the most advanced and widely used propulsion systems in modern space technology. In these rockets, the fuel and oxidizer are stored separately in liquid form and are supplied to the combustion chamber only when the engine is operating. This arrangement provides excellent control over the combustion process, allowing engineers to regulate the thrust according to the mission requirements. Since the fuel and oxidizer are highly reactive chemicals, even a small leakage can create a serious fire or explosion hazards. Therefore, liquid rocket engines require leak-proof tanks, pipelines, valves, and sensors. Another major challenge is the use of cryogenic propellants such as liquid hydrogen and liquid oxygen, which must be stored at extremely low temperatures using insulated tanks. Although liquid propulsion systems are more complex than solid rocket systems, they provide higher efficiency, better performance, and a greater flexibility, making them suitable for satellite launches, space missions, and reusable launch vehicles. The next slide we are going to see about the definition of liquid propellant rocket system. A liquid rocket propellant rocket is a propulsion system in which both the fuel and the oxidizer are stored separately in liquid form and are supplied to the combustion chamber through pumps or pressurized tanks. Inside the combustion chamber, the fuel and the oxidizer mix together in the correct ratio and undergo controlled combustion. The combustion produces very high temperature and high pressure gases which expand through a convergent divergent nozzle to generate thrust according to the Newton's law of motion. One of the most significant advantages of liquid rocket engines is that the engine can the thrust can be controlled by adjusting the flow rate of the propellants. Unlike solid rocket motors, liquid engines can be throttled to increase or decrease the thrust, shut down whenever required, and restarted multiple times during the mission. These unique capabilities make liquid propulsion the preferred choice for the orbital launch vehicles as well as spacecraft and human space exploration missions. Next, we will see the major components in the liquid propulsion rocket systems. A liquid propellant rocket consists of several important components that work together to produce the thrust efficiently. The fuel tank stores the liquid fuel, such as liquid hydrogen or RP1 kerosene, while the oxidizer tank stores the oxidizer, commonly a liquid oxygen or a nitrogen tetroxide. Since the fuel and oxidizer are stored separately, accidental combustion is prevented before entering the engine. The pump or pressurization system transports the propellants from the tanks to the injector at the required pressure. In high performance rockets, turbo pumps are used because they can deliver large quantities of propellant at extremely high pressure. The injector sprays the fuel and oxidizer into the combustion chamber in fine droplets to ensure the rapid and uniform mixing. The combustion chamber is the location where the propellants burn, producing high temperature gases with enormous pressure. Finally, the nozzle converts the thermal energy of these gases into high velocity exhaust gases, producing the thrust that propels the rocket forward. Each of these components plays a critical role in ensuring safe, stable, and efficient engine operation. And with respect to the applications point of view, liquid propellant rocket engines are widely used in various space applications because they have of their high efficiency, controllability, and reliability. One of their most common applications is in the satellite launch vehicles, where they provide the precise thrust required to place satellites accurately into orbit. They are also used in the upper stages of launch vehicles, where the engine may need to restart after the initial launch to insert payloads into the different orbits. Another important application is in the spacecraft maneuvering engines, which perform orbital corrections, attitude control, and docking operations. These engines require precise thrust control, which is possible only with liquid propulsion systems. Liquid rocket engines are also essential in human spaceflight missions, where the astronauts require safe, reliable, and controllable propulsion during the launch, orbital operations, and return missions. Modern launch vehicles developed by ISRO, NASA, ESA, as well as SpaceX extensively use liquid propulsion because it provides high specific impulse, as well as a better fuel efficiency and mission flexibility compared to the solid rocket systems. So that's all about liquid propulsion systems. We will see another topic in the next section. Thank you all.